In this video, we're going to take a look at some examples of expanding logarithmic expressions. We'll start with one logarithm and maybe go to two or more. So expand each of the following and simplify numerical values when possible. Assume all quantities represent positive real numbers, so we do not have to worry about any domain issues. So example 1a, we have log base 2 of 8 over x. And because we have a logarithm of a quotient, we can apply the quotient property to separate this into two different logarithms. So we'll have log base 2 of 8 minus log base 2 of x, the log of the numerator minus the log of the denominator for the quotient property. Now log base 2 of 8, we can simplify that because 2 to the third power equals 8. Log base 2 of 8 gives us 3. So when we simplify that, we get 3 minus log base 2 of x. Part B, we have log base 0.1 or log base 1/10 of 10 times x squared. So we have a product inside these parentheses, 10 times x squared. So we can use our product property to separate them. So log base 0.1 of 10 times x squared is log base 0.1 of 10 plus log base 0.1 of x squared. Now looking at this log base 0.1 of x squared first, we have a power for what we're taking the logarithm of, so we can use our power property to move that 2 that's in the exponent down in front of the logarithm. So our next step will have still log base 0.1 of 10, but then plus 2 times log base 0.1 of x using our power property. Now log base 0.1 of 10 or log of 1/10 or log base 1/10 of 10 is saying what power do we have to raise 1/10 to get 10. We can actually simplify that because 1/10 to the negative first power is 10. In other words, log base 0.1 of 10 is -1. So our final answer is -1 plus 2 times log base 0.1 of x. Part C, we have the natural log of 3 over e times x, and that whole 3 over e times x is being squared. So we have this exponent 2. Let's bring that exponent down in front of our natural logarithm. So we have the natural log of the expression, of the squared expression, 3 over e times x equals 2 times the natural log of 3 over e times x using our power property for logarithms. Using our quotient property, the natural log of 3 over e times x, we can separate that as the natural log of 3 minus the natural log of e times x. So look at how the fraction bar looks like a minus sign, maybe help you remember it a little bit easier. So using the quotient property, we get 2 times the expression natural log of 3 minus the natural log of ex, or the natural log of e times x. Well, the natural log of e times x, we can separate that into two logarithms using our product property. So separating that into two logarithms, we have the natural log of e plus the natural log of x. We have this minus out in front, so we need to put the natural log of e plus the natural log of x in parentheses, and we can bring everything else down from there, the 2 and then the natural log of 3 as well. Now distributing this negative through to the natural log of e and the natural log of x, when we distribute that negative, we get 2 times the expression, natural log of 3, haven't done much with that yet, minus the natural log of e, and then minus the natural log of x. Now natural log of e is the base of the natural log is e, so we have e base of e, and we have an e that we're taking for our logarithm. The natural log of e equals 1, so we have 2 times natural log of 3 minus 1 minus natural log of x, and then finally we can distribute the 2 to each of these 3 terms, and when we distribute that 2, we get 2 natural log of 3 minus 2 times the natural log of x as our final answer. Part D, we have log base 117 of x squared minus 4. Now you might be tempted to think we're going to use the quotient rule here for x squared minus 4 and possibly the power property as well. However, we don't have any properties for logarithms that deal with subtracting what we're taking the logarithm of. That's only for multiplication and division and just a single term being raised to a power. But we can factor x squared minus 4 as x plus 2 times x minus 2. So when we do that, log base 117 of x squared minus 4, using our factoring, we get log base 117 of the factor x plus 2 times the factor x minus 2. And because we're multiplying factors inside this logarithm, we can use our product property to separate them. So we get log base 117 of x plus 2 plus log base 117 of x minus 2 using our product property. Finally, part E, we have a scary looking one, log of the cube root of 100x squared over yz to the fifth. Oh man, this one looks scary. Well, first of all, let's take care of this cube root here by remembering that when we cube root something, even this scary looking fraction here, taking the cube root of something is the same as raising that something to the 1/3 power. So the log of the cube root of 100x squared over yz to the fifth is the log of the expression 100x squared over yc to the fifth being raised to the 1/3 power. Now that we have this written as a power, we can use our power property to bring that 1/3 down, and we have 1/3 times the log of 100x squared over yz to the fifth. Using our quotient property for what we're taking the logarithm of, we get still 1/3 times, but now we have the log of 100x squared minus the log of yz to the fifth. Carrying on with that, we have with each of these logarithms, we have the log of 100 times x squared, and we have a log of y times z to the fifth. So we can apply our product property for this log of 100x squared, and we can also apply the product property for log of yz to the fifth. So when we break it up, we get still 1/3 out in front, but using our product property, we have a log of 100 plus the log of x squared, then minus the expression, the log of y plus the log of z to the fifth. Distributing this negative that's in front of the log y plus log z to the fifth, we get minus log y minus log z to the fifth. And then using the fact that log of 100 is 2, we can rewrite this first expression, log of 100 is 2. Everything else we can keep the same afterwards. And then with the x squared and the z to the fifth, we can use our power property to bring those powers down. So we'll get 2 plus 2 log of x minus log y minus 5 log z. And then when we distribute the 1/3 to everything, we get 2/3 plus 2/3 log x minus 1/3 log y minus 5/3 log z as our final answer. So a bit of a challenge there in example 1E. All right, so that about does it for this video. Thanks for watching. I'll